So in this video, we're going to talk about how to write the equation of a parabola given 3 points. So given 3 points on a parabola, you can write the equation of the quadratic function it represents using one of three methods. If you have the vertex in 2 points, then you can write the equation in vertex form. If you have just any 3 points, you can write a system of equations and solve it with matrices, or you can use a quadratic regression. So we'll see examples of all three methods in today's video. So let's start off with this example. So let's write the equation of the quadratic function that has a vertex at -3, 7 and passes through -4, 5 and -2, 5. So here you can see we've already identified the vertex, right? So remember, if we write the equation in vertex form, which is y equals a times x minus h squared plus k, the vertex is going to tell us the values of h and k. So from that -3, 7, we know that h is -3 and k is 7. So we can go ahead and plug that in. So we have y equals a times x minus -3 squared plus k, which is 7. Well, that minus negative, I'm going to go ahead and turn that into a plus. So I have y equals a times x plus 3 squared plus 7. Well, now what you can do is you can just pick one of these other points. It honestly doesn't matter which one you pick. Just pick a point. And so, for example, I'm going to pick -2, 5, and that's going to tell me my x and y values. So what I'm going to do now is I'm going to plug those into my equation. So I have 5 equals a times -2 plus 3 squared plus 7. So now you can see here I have an equation with just one variable. My variable is a, so I can actually solve this equation now to figure out the value of a. So I'm going to simplify this. I have 5 equals a times -2 plus 3 is just 1. So I have 1 squared plus 7. So that's 5 equals a times 1 plus 7. Well, a times 1 is just a. So that's telling me that 5 equals a plus 7. I can solve this equation now by subtracting 7 from both sides. So that tells me that -2 equals a. If I plug everything back in, that means I have my equation in vertex form. So that's y equals -2 times x plus 3 squared plus 7. So that's the equation in vertex form. Remember, if I want to, I can go ahead and convert this to standard form. I just need to expand this x plus 3 squared. So remember, x plus 3 squared is just basically x plus 3 times x plus 3. And if you expand that out, you'll see that you get x squared plus 6x plus 9. So I'll leave that as an exercise to you to go ahead and use FOIL or whichever method you prefer to multiply those two together. So when we plug that back in, we get y equals -2 times x squared plus 6x plus 9. And we have this plus 7 at the end. That -2 in front is going to distribute to every single term. So I have y equals -2 x squared. -2 times 6x is minus 12x. -2 times 9 is minus 18. Then I have plus 7. Remember, I always want to combine like terms. So I'm going to combine those two constant terms. So I have y equals -2x squared minus 12x minus 11. Okay, so that's my equation now in standard form. I can also, if it asks me for vertex form, I also have the equation in vertex form. Okay, so that's how you write the equation if you have the vertex identified as one of the 3 points you're given. So what if it just gives you 3 points and it doesn't necessarily tell you that one of the points is the vertex? Well, what you need to do now is do one of two methods. So one way is to create a system of equations and then you solve with matrices. So you can either do that or you can use regression. So let's look at this first way. So what you do is you just realize that every point represents xy, right? All of these are xy points. So what I do is I take standard form, which remember is y equals ax squared plus bx plus c, and I'm going to make an equation based on each point. Okay, so like my first point, -2, 22, I get the equation 22 equals a times -2 squared plus b times -2 plus c. Okay, so if I simplify that, that tells me that 22 equals 4a minus 2b plus c. So I'm going to flip this equation around. I'm just going to write it as 4a minus 2b plus c equals 22. Okay, so now let's write my next equation based on the point 17. Okay, so based on the point 17, I have 7 equals a times 1 squared plus b times 1 plus c. So I have 7 equals a plus b plus c. I'm just going to turn this equation around. So I have a plus b plus c equals 7. Okay, and now we have the point 4, 10. So let's go ahead and plug that in. So I have 10 equals a times 4 squared plus b times 4 plus c. So that's 10 equals 16a plus 4b plus c. And I'm going to flip my equation around again. So I have 16a plus 4b plus c equals 10. Okay, so now I'm going to write all three of these equations together. So you can see that I have a system of equations. So I have 4a minus 2b plus c equals 22. Okay, and then I have a plus b plus c equals 7. And then I have 16a plus 4b plus c equals 10. So I hope you can see now I have a 3 by 3 system of equations. And actually, I can solve this now using matrices and Desmos, right? I just need to add in my coefficients of 1. And you can see I can represent the system with this augmented matrix, right? So I have 4, 1, 16 in my first column. Second column, negative 2, 1, 4. Third column would be 1, 1, 1. And then I have my column with the solutions. So I have 22, 7, and 10. Okay, so what I'm going to do now is I'm going to go ahead and open up the matrix calculator. And so I go there. So I'm going to do new matrix. I'm going to tell it a 3 by 4. And I'm going to go ahead and enter all these values. And so I'm going to enter, and then I'm going to do, remember, RREF, and tell it to apply that to matrix A. You can see now it gives me the solutions, right? So it tells me 1, negative 4, and then 10. So those are now the values of A, B, and C. Okay, so remember what it is we were trying to find in this problem. We were trying to figure out the equation of the quadratic function that has these 3 points, right? So what this has now done is it solved for our 3 unknowns we had in the system. So it gave us the values of A, B, and C. So since we're trying to find the equation of a quadratic, we're not done yet. We need to take this A, B, and C, and we need to plug it into this equation in standard form right here. So what I'm going to go ahead and do now is I'm going to give myself some more room. So I have A equals 1, B equals negative 4, and C equals 10. So I'm going to plug this into y equals ax squared plus bx plus c. So that means y equals 1x squared minus 4x plus 10. You remember I can write this as y equals x squared minus 4x plus 10. And that is the equation of the quadratic function that passes through those 3 points. So given 3 points, you can also use a regression in order to write the equation of the quadratic function, okay? And this is what we saw in the previous unit. Remember, when we're writing in a regression, we're going to create a table. So I'm going to go ahead and create a table from these 3 points that I have. I have negative 2, 16, 2, 4, and 6, 8. So I'm going to go ahead and go to Desmos. Remember, create a table. And then I'm going to type in all these values. And then I'm going to do add regression. And remember, from the drop-down menu, choose quadratic, and then it gives me the equation of the quadratic function. Okay, so this quadratic function is going to be y equals 0.5 x squared minus 3x plus 8. Okay, so that is the third method you know of writing a quadratic given 3 points. So now you can go ahead and pause the video and try doing this example on your own. So here it says to write the equation of the quadratic function that's represented in this graph, and you can use whichever method you prefer. So personally, I think that regressions are the quickest way of doing this. So I like to just go ahead and take these points and create an XY table. And I'm going to use regressions in Desmos to go ahead and create this equation. So if I go ahead, I'm going to do this table, and then I'm going to type in all my values. And then I do add regression, and then from the drop-down menu, choose quadratic. And so now we have the equation of our quadratic function, right? That's going to be y equals x squared plus 3x minus 5. So given 3 points on a parabola, you can write the equation of the corresponding quadratic function. If you know one point is the vertex, you can solve algebraically using vertex form. You can also use matrices or regressions to write the equation.